Hello students, this is lesson 2, day 2, video 2, the last video of this day. This video is about polynomials in factored form, but this video is about putting it all together, everything you've learned so far for the past 2 days, and ultimately graphing these polynomials, graphing a sketch. So this is the video that you need to have out in front of you. The worksheet you need to have out in front of you. And please make sure that you complete it before you leave today to turn it in. Actually, you need to complete it before you take the quiz. You do have a quiz to do today before you leave. Let's discuss multiplicity of x-intercepts. We've talked about multiplicity a little bit, but let's make sure we have a clear idea of what multiplicity means. So here's a polynomial below, and it is in factored form because it has these parentheses. That's how we know it's in factored form. And so the answer for this part, hopefully you know that the answer for this is x equals positive 2. You just switch the sign. This has a multiplicity of 1 because you don't have a power on the outside. These other guys have a power, but this one does not. So this is a multiplicity of 1, and that means it's going to go through the x-axis. So this goes through the x-axis at positive 2. It's going to go through. This next one has a multiplicity of 2. The answer here, by the way, is negative 9. X equals negative 9. So because it's a multiplicity of 2, it's not going to go through the x-axis. It's going to touch at negative 9. It's going to bounce off, but it's not going to go through the x-axis. And I'll show you a picture of that in a little bit. So this bounces off the x-axis. So pretty much odds go through and evens bounce off. All right, let's talk about this one. So here the answer is x equals positive 7. It has a multiplicity of 3, so that means it's going to go through at positive 7, but it's going to have a flex, like a little S-shaped movement right there. I'll show you what a flex is. It's going to go through with a flex. And then this last one has a multiplicity of 4. The answer here, of course, is positive 5. You always switch the sign. So this x-intercept is at positive 5. It has a multiplicity of 4. So that means it's going to bounce off. It's not going to go through. It's going to bounce off the x-axis and touch the point positive 5, but it's not going to go through. Now, because it is the fourth power, when it bounces off, it's going to have this like flat bounce. Again, I'll show you what this looks like in a bit. Okay, so on your worksheet, you have this table. It's kind of like what I just talked about, the different multiplicities and what it does to your picture. But let me show you some examples now. So what does it look like if it just goes through? Multiplicity of 1. That would be this guy right here. It just went through, nothing fancy happened, it crossed the x-axis. What does it look like if it bounces off? If it does not go through and it just bounces off at that point? That would be this one right here. It was going, it touched, it didn't go through it though, it just bounced back off of it. It was going up, it hit the point, and then it went back down. So this is what it looks like if it bounces off the x-axis. This is what a multiplicity of 2 looks like, the bounce off. Okay, so for multiplicity of 3, I talked about this flex point. It goes through, but it flexes. What does that mean? It flexes. That would be over here. So it went through, okay, it went through, but it had this weird like flex movement where it kind of had a weird shape here. It didn't go through straight like this one over here. It had this, what they call a flex, where it kind of moves in this little S shape. That's what a flex point is. And the last example is a multiplicity of 4. It bounces off again, but this time the bounce is very flat. It's very flat. Let me show you what that looks like. That's this point right here. It bounced off, it didn't go through, but it's very flat. It's almost like it hit the line for a little while. So instead of just bouncing off quickly, like this one right here, multiplicity of 2, the multiplicity of 4 bounces off, but it's just flatter. And that's what we're talking about here. That's the behavior you're going to see on graphs depending on its multiplicity. All right, here's just one more example to show you. So here's an equation, y equals x to the 6th power. So this is not in factored form. This is in standard form. But I just wanted to show you that this has 6 answers, 6 intercepts. So here they are. Let me count them with you. So this is 1. It went through right here. So that's 1. Here's 2. It went through again. So that's another answer. And then here you have a flex. So that means there's 3 answers right here. This has a multiplicity of 3 because of this flex. And then here's another answer. So if you count them, they do add up to 6. Okay, so let's count them again. 1, and then there's 3 here. So 3, that's 4. This one plus this one is 4. 1 plus 3 is 4. And then 5, and then 6. Okay, so hopefully you're understanding now what these different shapes do and how it relates to the power, the degree of the polynomial. Here's another graph. Cubic just means it's to the 3rd power. So all of these are examples of what could happen in a 3rd power polynomial. This is your typical, it's the power of 3, so it has 3 x-intercepts, and here they are, 3 different x-intercepts. It crossed the x-axis here, here, and here. That's 3 times. But something else could happen. You could have that it went through once, and then you can have a bounce off. And remember, the bounce off means it's a multiplicity of 2. So you have 2 here, and then this one is 3. So here you have your 3 roots as well, your 3 x-intercepts. This one's a multiplicity of 2. That means it's a repeat answer. So that's another way it could look. And then this one, we're not going to talk about a whole lot, but I did want to just mention it, once or twice. This has 1 x-intercept, and then it didn't touch again. So that means that you have 1 real root or 1 real x-intercept. So it's just 1 real x-intercept. You do have 3 solutions, though. It just means that this is the only real solution. The other 2 are imaginary numbers, like that lesson that you just did earlier today, where you could get your answers being negative square roots, which means imaginary or complex answers. So that's what's happening in this picture. You only have 1 real answer, like let's say this one gives you a real answer, but then the other 2 give you imaginary answers. Okay, so that's the different scenarios. One more thing we need to talk about before we get to doing some practice problems. We've talked about that factored form is great because it gives you the x-intercept. And you know how to find the x-intercept. You make the y equals 0 and you solve it. And we did that the last video. You did that a bunch. But one thing I just want to mention is the y-intercept. It's pretty much the same thing. How do you find the y-intercept? It's very similar to this. To find the y-intercept, you make, instead of making the y equal 0, now you want the y. So you keep the y and you make the x equal 0. So it's very similar. Okay, and then you solve for y. And there will always be one answer. Okay, so I want to go ahead and practice that with you at least once. You're ready. You're ready to graph polynomials and show everything you know about them because you know so much. This is problem number 5 on your worksheet. I recommend that you pause the video right here and you try all the practice problems on your own. And then if you're stuck, unpause the video and watch how I do it. But the only way you're going to get good at these is if you do practice doing them by yourself. Or do as much as you can and then come back and watch the video. If you feel like you know a lot of it, perhaps a paraprofessional can check your work. And maybe you don't have to watch the rest of this video. But again, if you're feeling a little lost or a little confused, try it on your own, pause, and then play the video whenever you're stuck. I'm going to go ahead and finish up by explaining every single problem. Again, you might not need that, so you don't feel like you have to watch if you feel competent on your own. Okay, but here's problem number 5. Let's talk about the x-intercepts of this thing, okay? First of all, it has 2 x's, so that's a degree of 2. That means it's going to be a U shape. Now, let's talk about the 2 answers I have here. Switch the sign, so one of my x-intercepts is -2, and the other x-intercept is +3. So those are my x-intercepts, okay? This is the graph. So I need to make sure that I have a dot at x equals -2. That would be right here. I need to make sure to have a dot at x equals +3. That would be right here. Then I should, to be accurate, I should show the y-intercept. Okay, so again, let's practice the y-intercept. Instead of an x, I'm going to put a 0. Instead of an x, I'm going to put a 0. And now I'm going to solve for y. So what's +2 times -3? Okay, that's what these parentheses mean. You have to multiply these two. So 0 plus 2 is 2, and 0 minus 3 is -3. 2 times 3 is 6. A positive times a negative is a negative. So y equals -6. This is your y-intercept. So make sure you draw a dot at -6. Okay, and then connect your dots, and you're pretty much done. Now you might be asking yourself, but I didn't know how far down to go. Look at how this like curved down here. Teachers who grade the graphs and stuff like this, depending on what they're looking for, they might not care how far down you go, okay, or where this curve happens. That's actually a different lesson. It's a lot more work to figure that out. But honestly, most teachers, most professors, they don't really care about how far you make this dip. It's not that important in this lesson. So don't worry about that. All right, let's talk about end behavior. What happens to the value of the function as x approaches negative infinity? So, do you have to look to the left or to the right? Negative infinity is to the left. So as your eyes go this way, what's happening to your graph? Okay, as you go to the left, what's happening to your graph? It's going up. It's approaching positive infinity. So that's what you put for your answer. It approaches positive infinity. All right, next problem. Again, pause this video and try it on your own. Here goes. First step, recognize that this is 3 x's. So that means it's a degree of 3. It's going to have that S shape. Okay. The x-intercepts are going to be, you ignore the 1/4, and then you focus your attention here. X equals +1. X equals -3. Switch the signs. X equals +4. These are your 3 x-intercepts. Let's go ahead and graph these. On the graph, put a dot at 1. Put a dot at -3. And put a dot at 4. This is where your graph is going to cross the x-axis. All right, let's talk about the y-intercept. Oh, here's what the graph looks like. It went through your 3 points. And the y-intercept, let's talk about that real quick. Put your zeros in instead of an x, put a 0. And then multiply all of these guys. What's -1 times +3 times -4? Multiply, multiply, multiply. 1 times 3 times 4 is 12. It's a positive because a negative times a negative. These two negatives made a positive. And then bring down this fraction. It finally matters. You're going to bring it down because y equals all of these multiplied together. And 4 times 1/4 equals 3. So that's why the y-intercept is 3, and you graph it right there. Okay, so your graph is an S shape, and you did have to know that it starts down here and it goes through all the points you drew, and then it ends up going up at the end. That's how you know it's a positive S shape. It ends up going up at the end. All right. Let's talk about end behavior. What happens to the value of the function as x approaches negative infinity? So as you look to the left, what's happening to the graph? It's going down. So that's called, it's approaching negative infinity. All right, what happens to the graph as you look to the right? Okay, positive infinity is to the right. What's happening? It's going up. It approaches positive infinity. Okay, these are the answers for number 6. Number 7, pause this video and try it on your own. All right, for this one, it has 2 x's, so that means it's going to be a degree of 2, and it's going to be a U shape. But something that you need to know about this U shape is that it has a negative x and a positive x. Okay, look at what's in front of the x. It tells you if it's positive or negative. So x times x is x squared, but this is a negative x and this is a positive x. So it's actually going to be a negative x squared. That means that my U shape is going to be down. So just keep that in mind when you're graphing, that this is going to be a downwards U shape. Okay, now that we've talked about that, let's get started. All right, so the x-intercept is going to be, I'm going to go back. It's going to be, these two are actually the same answer. It's just switched around. We did some like this last video. So x is just going to equal positive 4 for the x-intercept. And it's the same answer for both. So it's a repeat answer. So what you need to know is that this has a multiplicity of 2 because you have the same answer. So it's just going to touch the x-axis at positive 4, and it's going to bounce off right there. So it's going to be a U shape going down, and it's going to bounce off at the positive 4. Okay, and we talked about it being negative x squared, a degree of 2. It's going to be a U shape going down. We talked about that already. So this is what it looks like. At the positive 4, it bounced off right there because it had a multiplicity of 2. Because these two answers were the same, it made it a multiplicity of 2. All right, what's up with this 16 down here? It crossed at negative 16. Let's talk about that. For the y-intercept, why did it cross way down here? Okay, so you put a 0 on the x spot, and you solve for y. So you have positive 4 times negative 4. What's positive 4 times negative 4? A positive times a negative is a negative. 4 times 4 is 16. So that's the y-intercept, negative 16. All right. Next question. It's about end behavior. What happens to the value of the function as x approaches positive infinity? So look to the right. What's happening to your graph? It's going down. No matter which way you look could look to the left or to the right. Both sides are going down. So the answer is it approaches negative infinity. All right. And this is the answer for number 7. Number 8. Again, pause the video, give it a try. So for this one, you have 3 x's. So that means you have a degree of 3. That means it's going to be an S shape. But if you look at, again, if you circle the x's and you focus your attention on the x's, you notice that one of them is negative. Okay, so this first one is a positive x, but this second one is a negative x. And then the third one is a positive x. So that means it's a negative x to the third power because of that negative in the middle. So when you draw this shape, it's that weird S shape, but it's a negative S shape. That means it's going to start up here and then it's going to, do something like this, and then it's going to go down. So that's what a negative S shape means. So watch out for that. All right, so let's move on and talk about the x-intercepts. Where does it touch the x-axis? The x-intercepts for this one is 3, because you switched the sign, right? So this is going to be positive 3. And then this one is also positive 3. So that means it has a multiplicity of 2. And so it's not going to go through. It's going to bounce off at this point. And then my other answer is x equals 0. Okay, so remember from the last video, when you have an x by itself like this, the x-intercept is just going to be 0. And it's going to go through at 0. Okay, we talked about the degree being 3 already. We talked about an S shape going down already. Let's talk about this graph. Let's go ahead and start graphing. So 0, that's one of your x-intercepts. It's going to go through at 0. It's going to go through. And then the other x-intercept was 3, but it's going to bounce off right here. So what's it going to look like? It's probably going to go from up here. It's probably going to go down through here. And then it's probably going to bounce off and then go down. So you started high, and then you ended up low. That's what the S shape is going to look like. Now, your y-intercept, I'm just going to show you quickly. If I put in the zeros, it's just going to be 0 times 0 times 0. Okay, I'm sorry, it's negative 3 times 3. But then this 0 on the end just made it all equal 0. Okay, because if you multiply anything with 0, the answer is going to be 0. So the y-intercept is this one right here. It's 0. And here's what the picture looks like. So it starts high, it goes through the 0, and then it bounces off at the 3. Now, if you didn't know to make this dip this low, it's fine. If you would have drawn your picture, something like this, something like that. Oops, I didn't quite touch the 3. But what I'm looking for is that you touched at the 0 and that you touched at the 3, but that you bounced off at the 3. That's what matters. This dip down here doesn't matter. So don't worry about, am I going to get this part right? That's not what's important in this lesson. Okay, so don't worry about that part. All right, let's go ahead and move on to the next question about, I believe it's about end behavior. Let's see. Here it is. Yes. What happens to the value of the function as x approaches negative infinity? So that's to the left. What's happening over here? It's going up. It approaches positive infinity. What happens as you look to the far right? Positive infinity. That's this way. What's happening over here? Oh, it's going down. Okay, so that means it's approaching negative infinity.